This is my 3-speed gearbox. This was built to demonstrate different mechanisms that can go into a gearbox. The 3 speeds here are selected by this driving ring. So the first speed here is a 1/3 gear ratio. The second speed is a 1:1 gear ratio. And the third speed is a 5/3 gear ratio. This may look pretty complicated, so right now I'm going to go over my design process, how I got to this design, and as well as what each of these little mechanisms do. The first step in making this gearbox was to make the shifter. Here I have a standalone model of the shifter, and this is just a drive neutral reverse shifter. So you can see that these 2 red gears are always going to spin in opposite directions because of these 3 bevel gears here. So in the first position, input and output are always going to rotate in the same direction. If I shift it into the middle position, the input and output will always rotate independently of each other. And in the third position, the input and output always rotate in opposite directions. The problem with this for a 3-speed gearbox is that in the center position, in the neutral position, it doesn't drive anything, and so this can't be used as a speed. The solution to this problem was to use differential. So now, when we're in the neutral position here, we'll just bypass the shifter and go directly through the differential. And then here, in the first speed, it will drive the differential through this 1/3 gear reduction. In the neutral position, again, it bypasses the gearbox. And in the third position, it spins the differential ring gear in the opposite direction. The problem with this is that when we're in neutral, you're able to just stall the output, and the differential's ring gear will back drive, and since this gearbox is not connected to the input, it will back drive. The solution to this problem was to use some sort of a non-back drivable mechanism. The simplest non-back drivable mechanism is here, a worm gear. When we crank the input, we can rotate the output in both directions, but as soon as we try and rotate the output, it locks up. The only downside with this system is that it has a very large gear reduction, and the input and output are perpendicular to each other. So I went with this non-back drivable mechanism, which has all the axles in the same plane. So you see here, we can drive it in this direction, but if I try and drive from the output, it locks up. And this has a gear reduction of 1/3. Here's the final product. So here are the 3 sections we talked about. Here is the drive neutral reverse shifter. Then here is the differential that adds the 2 speeds together. And then here is the non-back drivable mechanism. So right here is the first speed. The second speed. And the third speed. And now I'm going to go through the math on how to calculate the gear ratios of all 3 speeds. The first thing we need to understand for this gearbox is the differential. So we'll take into consideration this first differential here, with B being the input to this gear, E being the input to this gear, and D this ring gear, okay? So the equation for a differential is going to be, in this case, B plus E over 2 is equal to D, okay? And for here we want to solve for E because E is our output. So to do that, we can multiply both sides by 2. So B plus E equals 2 D. And then we can subtract B from both sides. So E is going to equal 2D minus B, actually. Okay. Now, let's go up to this differential here and solve for this. So it's actually going to be the same equation as down here, C, G, and F. Okay, so the two sides are C and F, so it's going to be C plus F over 2 equals G. Okay, and we can see that G here is actually directly connected to C through this 1/3 gear reduction, right? So we can say G is actually just a third of C. So let's put that in up here. So again, C plus F over 2 is equal to, now instead of G, we can just write 1/3 of C. Okay? Now, we want to solve for F because that ties directly to D, which is right here. And we need that to solve for our E. So let's multiply both sides by 2, just like we did before. So it's going to be C plus F is equal to 2/3 of C, okay? And now we can just subtract C from both sides. So F is going to equal 2/3 C minus C, which is just equal to negative 1/3 of C, okay? Now, we can pop this here directly into D for here because we can see F and D are connected through this 1-to-1 gear reduction, right? So F, we can just substitute that in for D here. And so we get E is equal to 2 times this F up here, which is negative 1/3 C. And then we subtract B, okay? Now B is directly connected to A here, which is our input. And that's going to be 1 for the purposes of calculating this gear ratio. So we can just set this B to 1, okay? So here, E is equal to, now we can multiply this out, negative 2/3 C minus 1, okay? Now, all we have to do is put in our value for C and we can get our speed out here, okay? So since this is a drive neutral reverse gearbox, like I talked about before, the C is going to be either 1, 0, or -1. So we can just put in 1, 0, and -1 for here and get our 3 speeds, okay? So for speed 1, C, let's just say it's going to be -1. So E is going to equal negative 2/3 times -1 minus 1. Okay, now we just do arithmetic here. E is equal to 2/3 minus 1, which is negative 1/3. So this is going to be speed 1. Okay, now for speed 2, we do the exact same thing, except we'll put in 0 for C, okay? So it's going to be E equal to negative 2/3 times 0 minus 1, okay? Now here, E is going to equal negative 2/3 times 0 is 0, so E is going to just equal -1. So that's our second speed. Now for our third speed, we're going to put in -1 for C, okay? So it's going to be E is equal to, or sorry, we'll put 1 in for C, okay? So E is equal to negative 2/3 times 1 minus 1, okay? Now, just say E is equal to negative 2/3 times 1 is just 1. So negative 2/3 minus 1 is negative 5/3. And that's going to be our ratio. So our three ratios are -1/3, -1, and -5/3. You'll notice that they're all negative. All that means is that this input and the output are always going to be spinning in the opposite direction. So this one, with speed 1, this is going to be spinning 1/3 of the speed. With speed 2, it's going to be spinning at the same speed. And with speed 3, it's going to be spinning 5/3 as fast as the input. I hope that all made sense. If you have any questions, please leave them in the comments below. Don't forget to like and subscribe. And if you want to build this for yourself, as always, the instructions will be at rebrickable.com. The link is in the description below. Thanks for watching.